Assalamu alaikum. Welcome back to my physics class. Dear students of standard 10, I know you are missing your traditional classes rather than the virtual class. So today I am going to take my virtual class in a classroom. So let's start the class. Dear students, today I am going to start a new chapter, that is chapter 10, and the name of the chapter is Static Electricity. In your syllabus, only 4 chapters will be left. So today I am going to start this chapter. Let's start the class attentively. Today's topics: basic concepts of charge and static electricity by friction. Basic concepts of charge. Dear students, if you comb your hair in winter and then hold the comb near the bits of paper, then you can observe this type of situation, this type of phenomenon. That means bits of paper are stuck to the comb. Again, look, in the winter season, in the cold countries, during winter, air is very dry, and when babies crawl on the carpet, their hair seems to stand straight like this picture, and it seems one hair is pushing the other. Again, look at this picture. All of you have seen thunderbolts during a stormy night and observed how flashes of lightning comes towards the earth. So, in the attraction of paper, repulsion of hair or thunderbolt, the basic thing behind these 3 phenomena is charge. To know what charge is and why charges attract or repulse or create thunderbolts, we have to understand the basics. We have to know how atoms and molecules are formed. We all know everything is made of an atom and molecule. Atom is the building block of everything, and nucleus is the center of the atom, and electrons revolve around the nucleus. The nucleus consists of proton and neutron. A proton is positively charged, and neutron is chargeless, and an electron is negatively charged. The electron which is revolving around the nucleus is negatively charged. The charge of proton and electron is equal but of opposite, and the magnitude of the charge is 1.6 × 10⁻⁹ coulomb. In an atom, generally there are same number of proton and electrons, so an atom is electrically neutral in charge. Electrons outside the nucleus do not revolve in the same orbit. Electrons in orbit close to the nucleus are strongly bound, but for some atoms, electrons in the outer orbits can be separated with a little effort. So normally atoms are charged neutral, and that means there are an equal number of protons and electrons in an atom. But if an electron is removed from the outermost orbit, because I have told you that in the inner orbit electrons are bound very strongly, but from the outermost orbit electrons can be separated with little effort. So for some case of material, so if an electron is removed from the outermost orbit, then the number of protons is more than the electron, and the atom is not electrically neutral in that case anymore. The amount of positive charge within it increases. If one electron is removed, one positive charge will be increased, and if two electrons is removed, then two positive charge will be developed. So in this way, an atom can be converted to charged from the neutral condition. In this way, an atom becomes charged, either positively or negatively. So now you have to know what is charge. Electric charge is the physical property of matter that causes it to experience a force when placed in an electromagnetic field. Electric charge is of two types, positive charge and negative charge. There are some facts about electric charge. Amount of current flowing in a conductor is measured in electric charge. The SI unit of electric charge is Coulomb. Electric charge is a scalar and fundamental quantity of a particle. Like charges repel and unlike charges attract each other. Look. So I have told you charge can be positive or negative. If two positive charges are taken nearer, then they will repel each other. Again, two negative charges also repel each other, but positive and negative will attract each other. Look, a charged comb picking up small pieces of paper due to static electricity. So static electricity is that electricity which remains static while it is produced. Look, what happens? How does this happen? After combing with the hair, what is the charge on the hair? When then what is the charge on the comb? What do the comb and hair attract? They are oppositely charged. How can we determine the charge that develops on each object? So look, when the comb, when we comb our hair, then what will happen? The comb will receive electron from our hair, and then the comb becomes negatively charged and our hair becomes positively charged. Then there will be attraction between comb and hair. In normal condition, the number of protons and electrons in any atom is equal. I have earlier told you. But every atom has got affinity for getting excess electron. This affinity for excess electron is different in different substances. That means different substances have different electron affinity. Like some of you have affinity of eating fast food. Some of you have affinity of eating vegetables. Like that, different substances have different amount of electron affinity. That is why when two bodies are brought in contact with each other, the body which has greater affinity for electron collects electrons from other body and gets charged negatively. I think the question can arise in your mind, when we comb our hair, then why the comb will receive electron from the hair? Because the comb has electron affinity more than that of your hair. That's why comb receives electron from your hair and becomes negatively charged, and your hair becomes positively charged after losing the electrons. Look, ebonite rod. When ebonite rod is rubbed with flannel cloth or animal fat, then what will happen? The ebonite cloth will receive electron from the animal fat and becomes negatively charged. So charge can be transferred from one object to another, and there are three methods of transferring charge. That is charging by friction, charging by conduction, and charging by induction. Look at the pictures. Charge by friction, charge by induction. There is no need of any contact, and charge by contact, or any kind of rubbing is required here. I will explain this later on. So now charge produced by friction. If a glass rod is rubbed by a piece of silk, electrons start to move from the glass to the silk. So the glass rod is positively charged and the silk is negatively charged. As I have told you, some substances have more electron affinity. They will collect the electrons when rubbing with another object. So that's why when silk, look, this happens because silk has more electron affinity than that of the glass. So if a plastic is wrapped using a flannel, or electrons will move to plastic on the flannel, because plastic has more electron affinity for electrons than that of the flannel. So look, when glass rod is wrapped with silk, then silk cloth has more electron affinity than that of glass rod. That's why silk cloth will receive the electron from the glass rod, and as a result the glass rod will be positively charged and the silk cloth will be negatively charged. Look, in the case of plastic rod has more electron affinity than that of the flannel cloth. So plastic rod will be negatively charged by receiving more electrons. So in this way, charge is transferred from one object to another object by friction. So look, uncharged cloth and uncharged plastic rod, but when they are rubbed, then the cloth becomes negatively charged and the rod becomes positively charged in case of glass rod. Now electric induction, where we know that when two bodies are rubbed together, electric charge is produced. Again, when a charged body is brought in contact with another neutral body, the latter is charged. When the neutral body is placed not in contact with the charged body but close to the charged body, the former becomes charged. Earlier you have seen when a comb is rubbed with your, when you comb your hair, then the comb becomes negatively charged, and when it brought near to the pieces of paper, the pieces of paper will stuck to the comb. So that happens due to friction or due to rubbing. But when neutral body is placed not in contact with the charged body but close to the charged body, the former becomes charged. That means neutral body becomes charged. This happens due to induction. The process of charging a neutral body by bringing it very near to the charged body is called electrostatic induction. You must memorize all the definitions. With a simple experiment, the electrostatic induction has been explained below. Look, positively charged glass rod, when brought near a neutral sphere, then in the neutral body, positive charge and negative charge are scatteredly distributed. But when the positively charged glass rod is taken nearer to the neutral body, then what will happen? All the negative charges will accumulate in this side because there is positive charge, and due to the attraction of the positive charge, the negative charge will be in this portion of the sphere, and the positive will repel each other. That's why positive charge will be at far distance. Understand? So this is electrostatic induction. That means when charge is produced in a neutral body by taking another charged body very close or very near to it. Look, it is a charged body, positively charged object, and neutral object where positive and negative are scatteredly distributed. but when it is taken nearer to it, then what happens? All the negative will be accumulated near to its side. Dear students, there is another example. If you rub a balloon with a sweater, woolen sweater, in a woolen sweater, when it is in neutral condition, the positive and negative charges are distributed scatteredly, randomly. But when the balloon is rubbed with this woolen sweater, then what will happen? The sweater will lose electron and the balloon will receive electron, becomes negatively charged, and the sweater becomes positively charged. Then if you left the balloon, then what will happen? The balloon will stuck to the wall. That means when the balloon gets stuck to the wall, the positive charge of the wall, again in the wall also neutral, so in the wall both positive and negative charge can be distributed scatteredly. But when the balloon is stuck to the wall, because at that time the positive charge of the wall will attract the negative charge of the balloon. That's why when you left any balloon, then after rubbing with woolen sweater, then the balloon will stuck to the wall. You can also do this experiment. There is a question. Suppose there are two metal spheres. Is it possible to create two types of charge in the two spheres with a positively charged glass rod? Look, in this way. Okay. Yes, it is possible. When the glass rod, which is positively charged, taken towards the two when two metal spheres, then what happened? The negative charge will reside in this portion, and the positive charge, as positive repel each other, positive repel, so it will be in the far distance. So in that case, by taking the positively charged rod near to the sphere, this rod becomes negatively charged, and this sphere becomes negatively charged, and these spheres become positively charged. Look here, electron, these two spheres is in contact with each other, and you know, through metal, electrons can easily transform from higher potential to lower potential. So, lower potential to higher potential. So, when these two spheres are in contact with each other, then from these sphere also electron will be transferred to this sphere due to the attraction of this positively charged object. Then these sphere will be negatively charged and this sphere will be positively charged. In this way, two spheres can be separately charged by the presence of another charged object. So dear student, today my class is up to this. In the next class, I will explain some more important topics. So till then, stay safe and stay sound. Goodbye everybody.